And so how we can measure the performance is we use a tool called Errant, which is developed by Chris Bryant. And what that does is it automatically extracts the edits from parallel, original, and corrected sentences. And then it classifies according to a series of rules. And so you see here, it's classified, well, here we've got replace the verb, and you've missed the determiner. And so this allows you to automatically take originally people used to actually mark these tags, but it took too long. But there are some issues, of course, that we use in spoken language. It means that if you start with ASR or you start with manually corrected text, the alignment's different because, they might have different sequences. Also, the edit rules don't take speech into effect. So if there are disfluencies, if there's partial phrases, that's not included. So how well does it work? Well, if we take the speech data and we do the manual transcriptions, manual and segmentation, and remove all the disfluencies, it actually works pretty well. It works very similar to the written text. So the written text, just to be clear, is slightly lower than you'll see in the literature for writing, because that 25% of errors from punctuation and spelling, they're the easiest errors to fix. So we're doing the harder part of them. But when we then look at actually the fully automated system, so we have to slightly change the metrics to take this into account. What we see is that there is quite a lot of degradation at the moment. So there is quite a lot of degradation through the automatic system. And what we see if we look at analysing them, we see that the top 5. We get we get the same top 5 errors being detected by all the systems, whether it's manual or automatic. And there's 3 real edits in there, missing determiners, unknown determiner, and a replacing of preposition. But there's also a lot of what's called other, which is what Errant will put anything it doesn't know. There's an error, but there's an edit, but it doesn't know how to classify it. And we see there's a large number of these, and this is because at the moment it's not quite speech-like, so it doesn't know how to handle them. So I said the performance is not great. Can we move somewhere from cascade towards end-to-end? So we have looked at a number of techniques to try and sort of more tightly integrate the modules, such as joint training and embedding parsing. So what about using this for assessment? So if a typical grader will take the speech in, we then we can extract some features, and these features I use handcrafted because some of them are sort of, a human has said that, we want to count the number of unique words in the sentence, or we care about, but other ones are more learnt. So things like pronunciation distance feature, phone distance features. So we compute features both from speech recognition output and from the audio. And then those features are fed into a grader like the deep density network, and we predict a score. And so we can use the spoken GEC as an additional set of features, additional input into our feature generation. Alternatively, we can sort of say, well, what if I try and take each of these views, these single view, and grade each one independently? The only issue we've got is that the scores are on a holistic level. So we don't have a score specifically for grammatical accuracy, specifically for pronunciation. But what we try and do is we constrain the features to be from that view, and we hope that will allow us to predict on a specific aspect. And the approach we've used for this is that we basically have a spoken GEC system. We then pass it through the Errant tool to get a sequence of edits, and from which we can use counts and probability of errors given the grade. And then we pass it through into a sort of BERT-like system where we have an embedding layer and then multi-head attention. And you'll see that the errant labels are over specific grades. As you move away from this particular grade, the distance, this is a KL distance, the KL distance gets greater. So we do see that there is a linkage between the edit sequences we see at different grade levels. And so we can score from that. And we get reasonable performance, but it's not as good. It's one of our weaker predictors at the moment in terms of assessment, but it can be used to combine in a multi-view assessment system, which helps. If I'm looking at feedback, so we can assess it. So now we've got some assessment, we've got some spoken get. Can we feedback? And this is this is still in stages. I was looking for this talk. It's like, well, what are people doing? And literally there were 2 cases I could find where people are actually giving feedback right now on spoken get. One was an academic paper this year, which was sort of taking a very simplistic approach to feedback. So they basically took a cascade structure similar to what I've been talking about, and then they put on this generation pipeline. It was quite simple. So people got a little gain from it, but I think in some ways it was too simplistic, the UI and forms. Apologies for the pronunciation, you show actually will give you grammatical feedback through their English learner. They've not published anything on this, so I don't know exactly what they're using. But obviously what we'd like to be able to do is maybe go something more towards what people are doing on the writing side, which is to give, more direct feedback. And that direct feedback can be a sort of more hints. So sometimes it can be very direct. This is the error you made, but it could just be a hint, look at this area and think. What we've seen that the spoken GEC is okay, but there are, it is errorful. So how can we, all the things we can do to pre-process it before we feedback? So one thing we can do is just remove that other tag. So don't give feedback on the other. It's very ambiguous, so it's not really informative to learners. The other thing we can do is improve the precision by filtering. So we actually have confidence measures for each module. So the ASR, it's the ASR confidences that you'll all be familiar with. But we can also get a sort of confidence measure for the fluency and for the GEC. And then we can sort of weight them individually and combine them. And we can either do this on a sort of whole sentence level or on a specific word by word basis. And we found that the sentence level approach works better. And we see that there's a number of types, error types, to more error types tends to improve. There's a few cases where it does actually degrade a bit. And in some ways, not surprisingly, is that if you look on a sentence, it's quite hard to say that replacing a noun should be changed. It's quite a difficult thing to know. So what are the open challenges for spoken GEC? So clearly accuracy is important. We need to look at as a field, can we more tightly integrate modules? Can we augment the data? Maybe adapt GEC networks more to the domain? Also, we really need our systems to know when they don't know. And so, when was it a good GEC sequence generated? When was it a bad one? And the other aspect that obviously for learning in particular, but also from this aspect of somebody coming back and say, well, why did you give me that mark? Interpretability and explainability is very important. So what caused the grammatical error? So the error here was her. He started her new career, and the reason the her was because it was a he. So her is female, he is male, so the two don't go together. So that's the work in the lab. And then I thought, well, I'm doing this talk, and OpenAI have just released ChatGPT. And so I wonder whether it can do spoken grammatical error correction. Obviously, I can't feed in audio, but I could feed in is speech text. And we were talking about, transformers are all you need. Large transformers are all you need. So are huge amounts of data and compute all we need? So this is a transcript. So this is a transcript of what was, so it's manually transcribed what was actually said, but I stripped out all the punctuation. So as if we had perfect speech recognition. And you'll see there's a number of disfluencies in there. I put in ums and ers, and well, I have to say it's just done an amazing job. It stripped out all the disfluencies. It found all the error mistakes, and then it even tells me why it did what it did. I made a few changes. I added the missing article "the" before the first chart and second chart. So, yeah. Well, I was personally very impressed. That's great. So, but remember, it is 175 billion parameters, and when I went back to last night, they were saying, "Oh, well, we're just adding more computers," and somebody reckons they're maybe spending maybe 0.03 cents per computation, so maybe $100,000 per day. So yeah, not all of us can do that. But also, more to the point, is that ASR errors, though, that issue of an unrecoverable ASR error is still an issue, and obviously the fact that we're just putting in text. So this was one where the ASR should have said, "I think my strongest skill." And instead it said, "I think my stall language skill is have fast range." So what's happened is it's done a good job. It's done a very good job at correcting it, but of course it thinks that it's thinking about language skills. So I think my language skills have a fast rate of improvement. And that's not what the person was actually saying. So even ChatGPT has there's still some problems that that left to solve. So to conclude, I hope I've shown you that. So automated assessment is growing rapidly, and one of those areas that we want to give feedback on is grammatical error, as in grammatical accuracy, because learners increase in these as they go on. And hopefully I've shown that it is of use for spoken grammatical error correction, is of use for assessment of feedback. There really hasn't been that much work in this area. And so there's lots of open challenges there. And it'll be very interesting to see this sort of being applied to other languages, especially ones where there's maybe less, it's the grammatical side is more difficult than English. So just to finish off, I'd like to thank particularly Edie and Stefano for various pictures that I borrowed from their presentations, and the members of Alta. The annotations were produced by Diane Nichols and her team at Elite, and we're funded by CUPNA. And thank you to the organisers. I would have had this as this is my home view that I missed on Monday morning. So I just had the cold of the air conditioning. Oh, my battery's on. Is that one? So I just had the cold of the air conditioning rather than the cold of the snow. Okay, any questions?
Thanks for the great talk, Kate. I think that this is a really challenging program. And you also mentioned the data is challenging. I'm wondering, because of this kind of grammatical error, disfluency, hesitation, individual impact, can you just do this kind of reverse data augmentation with the correct grammar, this kind of sentence, and add in this kind of disfluency, hesitation, and simulate some grammar error, and then even call TTS to synthesize the data, then you may be able to do some end-to-end training.
Yeah, that's a very good question. In fact, that we had a student looking at that. He tried two things. One was to take the written text and add in speech-like disfluences, And one was to also take something like some native sort of speech and try and make it more learner-like. The latter didn't work. The adding in speech disfluencies to the written text did give us some small improvements. So yeah, that's definitely something we want to do more of. And I think that is, yeah, that's really from this seems to be where the in terms of data augmentation, a good place to focus. Yeah.
Thank you. That's a great talk. Thank you very much. So my question now is about for this line of research, what are the real challenges here? So you talked about the data, or especially the annotated data, right? So what are missing in this line of research, especially from the academic research point of view? We are not being able to compete with Google and any of these big companies.
Yeah, I think from academic research, the thing at various stages that has held us back is data, is annotated data. So as you saw, so they previously we were working with only, I think, about 1,000 annotated data. We had the NICT. So, and now we're up to 3,000, a bit more coming. And that is the real issue of. So obviously you need enough to evaluate at least.
3,000 hours, right?
No, 3,000 utterances. Yeah, 3,000 sentences. So that is, and that, you know, so it takes time to annotate. And this is we would love to work more. We're doing work on conversational speech because obviously, you know, face-to-face communication is a big one, but the issue there very much is data. So yeah, so annotating is. Annotated. Some of it's so for grammatical error correction. Some of it is getting annotations, and obviously then there's just getting data for maybe self-supervised approaches. But there's still issues with just raw data.
Great. I have more questions, but I will take a kind of leave.
Okay. I think there's one at the back. Yes.
Thank you for the talk. It's very interesting. You shared a lot of vocabulary, error, grammar, error, and fluency detection. My question is that for speech evaluation, there's another perspective, that's the intonation. I want to know, could you share some insight of the position of intonation in speech evaluation?
Yeah. So we stop sharing my. So we built a sort of automatic intonation model for assessing. So we were using so we basically we do alignment. So we do a phonetic alignment, and then from that we convert it into consonants and vowels, and we use, you know, distance measures that people use in assessing intonation, like PNVI, and so this sort of idea about the duration of verb sequences and consonant sequences. So the intonation performance is it was similar to the pronunciation. So in terms of our assessment level, you've got text is pretty good. I mean, it's almost as good as if you add in all the features. Pronunciation's about halfway between pronunciation and intonation, about halfway between there and the get. So it's doing okay, but we can definitely do more. And I think feedback is something we'd like to look at, but we haven't really had a chance to do that yet.
Thank you for the talk. I have two questions. The first one is on slide 46, you show the pipeline that you can do like a weight over the confidence in each of the pipeline. But what is the prediction of the confidence? How do you usually say that? You say that what's known as overconfident prediction. Is there a way that you can know that to take different kind of decision?
Sorry, can you just say the last bit?
Is there a way to utter or be aware that these values are not overconfident predictions.
Oh, that they're not overconfident. Sorry, can you just repeat that? Be aware of.
Yeah, because I mean, so you have this time word and confidence score, but what if the model is actually giving you way much more confidence than what the reality is?
Yeah, that is one of the things we're looking at. So as I was saying, we've been doing some work on end-to-end ASR, because the confidence metrics that come out of that, everything's good. Every word is perfect. So Google proposed something like a separate confidence estimation module, so that it's something that sits on top as you post-process, that sits on top of your outputs. And we've seen some improvements with that, but we're still working on that. I think confidence estimation is still an unsolved problem, especially when you start to then look at things like disfluency detection or GA.
Maybe not directly so related. I do remember maybe a year and a half ago, I did some work where we measure uncertainty on the scorer based on the self-entropy of the predicted distribution of an assembly of models. But actually, that sounds very expensive. So can you talk more or less about what are the challenges in this ensemble framework when it comes to deployment?
For uncertainty?
Because I remember that it was very good because we checked the entropy of the ensembles, but it might be very expensive. So another ways can be done to make it more efficient.
So, so one of the things to make things less expensive, a lot of work in our models, because obviously the other thing is when you're dealing with neural networks, deep learning, they are highly dependent on initialization. So did you pick the right one or not? So what we tend to use is an ensemble of models in many cases. So our grader, maybe 3, 10 models, and then we combine. That does then give us the advantage that we can then use the differences between them and predictions as a measure of uncertainty. But what we can then do is use distillation. So distillation is one metric way we're doing it. So we distill multiple models into a single model, and so ensemble distribution distillation is really where we see the way to handle computational aspects.
Are there any questions? I think we could have a few more short questions. You said you want to ask one more question. I can come up with
Thank you very much for a nice talk. I want to ask, what would it take to implement grammatical error correction for a language that is different from English? So is there any way how can you use language resources for English in another language? Thank you.
Yeah, so I think, I think what you could do, obviously there are pre-trained models, like Grandformer that are English. I don't know how many there are what I would probably do is try and find one in a language that was similar. But you would, certainly at this stage, we're not on fully self-supervised. So you would need some amount of data that was annotated. As I say, so people used to the Cambridge Learner Corpus, which is they're still growing. They still have people used to sit there and mark individual errors types, and that's very expensive. It's much quicker to mark errors, but you would need to have a certain amount. What we had found, in terms of how much you need to do, we for grammatical error detection, what we did, we only had 1,000 sentences. We would take, say, 900 and fine tune on 900 and predict on 100, and even with that very small amount, we did get reasonable performance. So I don't think you need a massive amount, but you do need, you can't do it without something, unless you're going back to rules. So that's the other.
just a follow-up question. And in terms of this annotated data, right, what holds the problem or the task back? So let's say if we have a lot of language teachers there anyway, right? So if they do this annotation as part of their job, and can this be automatically kind of taken into the pool of annotated data? Do you understand my question?
No, I can't quite hear properly.
Oh, okay.
Or maybe.
So because these are about language learning, right?
Yeah.
So typically we have, in our case, our university, right? We have a lot of students who wants to learn English as a language or other languages, right? The teacher will do their correction anyway. So can this be considered as the annotated data?
Yeah, I mean that is the hope, that to work both with found data, but also use sort of human in the loop. So yeah, can we take data that's, and I think this is the other thing about once these systems are being provided electronically and so not on paper, then, and there are, especially the Write and Improve app, there are actually a lot of teachers using it. They can then reuse that data to give feedback, see how their class is doing.
Because these are going to be the real data.
Yeah, I mean, there's no data like more data, but there's no data like real data as well.
Exactly. Thank you.